In problem number 15, we're given various statements concerning the location of an extreme value of a twice differentiable function f, and we're asked to identify which one also includes a correct justification. Let's start one at a time. In statement A, they're telling us that f has a maximum at x equals 5 because f prime of 5 is 0. So it tells us we have a critical number at 5, but we don't know anything about the behavior of f to the left of 5 or to the right of 5. So we need more information. Statement A is out. Statement B, the function f has a maximum of 5 because f prime is less than 0 when x is less than 5, and f prime is greater than 0 for x is greater than 5. Well, let's see what that tells us. They tell us f prime is less than 0. In other words, f prime is negative when x is less than 5. And f prime is greater than 0, or f prime is positive when x is greater than 5. This one's a little tricky because they say that f has a maximum at x equals 5, but from the information they stated, it looks like f prime changes from negative to positive, stating that f has a minimum at 5. So it looks like B is out. Let's go to statement C. Function has a minimum at x equals 3 because the tangent line at x equals 3 is horizontal. Well, if the tangent line is horizontal, that means the derivative of the function is 0. But again, we don't know what's going on to the left or right side of x equals 3. We need more information. C is out. Now D. F has a minimum at x equals 3. So we'll label our sign chart with a critical number at 3. Because f prime is less than 0 when x is less than 3. Well, if f prime is less than 0, it means f prime is negative. F prime is greater than 0 when x is greater than 3. In other words, f prime is positive. So it looks like f prime changes from negative to positive. We have a relative minimum. D looks like it is true. Let's just check to E to see if there's any trick that we overlooked. Function f has a minimum at x equals 3. Because f prime prime of 3 is less than 0. Now wait a minute. This includes something that we haven't discussed at great length in our class, the second derivative test. If f prime of 3 is 0, we can tell the behavior of our function when x is 3. It tells us that f prime prime of 3 is less than 0 or negative, which means our function's concave down. If our function's concave down, then there would actually be a maximum, not a minimum. So the best description here is option D. Hopefully this was helpful. Thank you for watching.